Hello everybody, welcome back. As the title suggests, I intend to build a little power supply using bits and pieces that I've had laying around for years, some of them decades. Just as going to be a simple 24 volt, probably a twin, two 24 volts, 25 volts, either using this is a Naim, out of a Naim high cap, an M317. This is the Avondale TPR4. You would have seen that in a previous video. Very good module indeed. Or I have the Avondale, this is the shunt regulator. Very good piece of kit. This surpasses all of them in my opinion. But we're going to knock up or build up a power supply predominantly for a preamp or such like. We can alter the voltage up and down a bit, but it's a little bit daunting really. But as you can see, over the years I've used all sorts of regulators, rust white shunt regulators, NARS, tracking pre-regs, Teddy Pardos regulators. This is something out of a what they call a snaps, Naim snaps. So this in effect is this is the beefed up version if you like. LM317s, both the same. In effect the circuitry is the same, but it's on a more substantial heatsink, blah blah blah. We have a little multiplier here. Now these are very good. Lovely little bit of kit this. Gyrator. Knocks off all the crap off the rails. I'm probably going to use this type of transformer. EI square. Very good. They produce great sound. I've got a couple of toroidals here, 500 VA, some capacitors, 20,000 microfarads, BHC, so 63 volt. These are very good, very popular. So that's what I intend to do. We've got loads of these things out of snaps. So that's a starter for 10. I will probably use, this is my favourite to go to rectification. These are rectifiers on here. And it's the Avondale Audio one, but you can knock them up yourself if you so wish. There's the ceramic type used everywhere. This is something I had knocked up. I haven't decided yet, but I have a completely brand new chassis here with a sleeve that goes in there, so everything fits inside there and just slides in, and you end up with in effect a finished unit. But I'll probably use this one here since it's already drilled. As you can see, I've done lots of previous adaptations of power supplies. I probably won't use these little ones, I'll use one big one, but that's a starter for 10 just to get us going. So these are the bits I've decided to use in this bits and pieces power supply. I'm going to use this BHC 15,000 microfarad, 63 volts. That's going to go roughly there. I've got an Avondale rectifier bank. There's 4 MBR 2200s, 20 amp 200 volts, and I'm going to use the Avondale shunt rig. As previously mentioned, this old chassis, it's not commercially viable, and this would be just used in my system. And I've got to drill some holes to put some, to fix it. You can't fix this to thin air. So a couple of holes in the back there. It'll go something like that. This is a 500 VA transformer. It's 115 volt primaries, and it has, in actual fact, 6 secondaries. 6 24 volt outs, and I've paralleled them all up here, and it comes out as one. You don't have to parallel them all. It was just an experiment I was playing with, just to see if there's any sonic benefit. It doesn't appear to be so. But my first job, I've got a bit of strapping. I've got to make a saddle to go around this capacitor to fix it to the chassis, and I'll go into how to do that. This is just a thin piece of aluminium. It doesn't have to be substantial. It's quite thin. What's that? 2 inches wide. And we're going to make a saddle, and I'll drill some holes, and that'll clamp that down. You could glue it down if you wanted with hot glue, but I don't tend to do that, because with the DIY I do, stuff's being taken out, put in, taken out, put in, rebuilt, reused. So I like to screw everything down as opposed to glue. So I'm going to move the camera and I'll just show you how I make one of these saddle straps. So I've got one of these little twiddly bench vices that you can move about. It just so happens that I'm doing no measurements here. This is all by eye. Now I just put my strap in here at 15 mil, something like that. I can cut it off, make sure it's sort of relatively upright to start with in this vise, and I'm just going to bend that down like that. And that's our first fixing. So now what we have to do, that's going to be like that. We form this aluminium round the capacitor. So I'll just move this out of the way for a second. So you stick it on the edge of the bench, something like that. You use your bench as your basis of the chassis, hold that down, and you just form this round, force it round, force it round, force it round, till it becomes strapped to the capacitor like that. And now we need a mark so that we can bend the fixing this way, back this way. But first of all, I'm going to cut this off at appropriate length. You've got to give it a bit of a jiggery pokery, but it'll be fine. Just like that. I'm just going to make myself a mark. So our mark is going to be there. So this is very thin, but I'm going to give myself a bit of, but we're not holding up anything too much, are we? Let's bring this back. So we now reclamp this up to our mark here, plus a bit. There we go. Something like that. And we bend that back like that. We end up with something that approximates a strap. Now I'm being very swift and very, very inaccurate, but I'm doing it by eye. But you end up with a saddle strap just like that. Just tease it a bit more. You can also use a scaffold for these 50 mils. You can also use a scaffold tube if you've got a scaffold tube. I haven't. I use the capacitor. Just like that. How's that? So we now move that out of the way. This transformer is already screwed onto this well used sleeve chassis. It's screwed by a big 20mm Allen bolt that goes up through the centre of the transformer. As you can see, I've used this. I can't see this. Let me just there we go. You can see I've used this chassis for about 20 years for all sorts of different power supplies, power amplifiers, regulators, all sorts of transformer configurations over the years. But I tend to reuse an awful lot for myself. It's not, wouldn't be, I wouldn't sell it, but just to give you some idea of what I do. As I say, it's a DIY video. So I'm just going to go away now. I'm going to drill some holes, which I won't bore you with. It's just drilling some holes. I'm going to drill a couple of holes, one here, one the other side. I've got some countersink M3 countersunk screws that's going to come up and screw that down. If this is a bit slack, I don't think this one's going to be, but if you do find that if you do this and this capacitor is a bit slack, you can always put a bit of foam or a bit of tape on the inside, and that would securely mount it, stop it moving. It's the easiest way. So I'm going to go away, do some screwing, do some drilling. I'll be back shortly. So I've drilled a couple of holes, countersunk them, and the strap goes across like that, and it's firmly in place. And now I want to fix this regulator module this side of the chassis. So I've already drilled one hole, well actually it was already there, countersunk it, and these are held on with M4s countersunks. So that's the one. So I now have to set up for a second hole up here for this. It just so happens that this is 66mm, so I'm just going to scribe a line down through the centre of there. And I'm going to measure 66mm, double check, centre to centre. In actual fact, I'm going to say 65, measure 65. So if I go 65 from the centre to there, there's my mark there. I'll just align those. In actual fact, that is 66. It's going to have to go that way a little bit. I do tend to over drill, oversize these holes to give you some wriggle room, but somewhere around about there. Bear with me a second. I'm just looking for my centre punch, which I can't see. It was here, it's not anymore. Oh, that's gone. Alright, I'll be back. So I've drilled and countersunk that one there. I've cleaned off all the swarf and high edges. So now, by the way, I've just built a couple of screws on here to fix on this rectification diode bank here. So that's fixed in place. I'm just about to see if this fits actually. So there's a couple of mounting holes on the back, one there. As you can see, I took the transformer out to do this. And there should be one just there. Perfect. Perfect fit. Now before I finalise this location, what I am going to do, that fits perfectly, so it's a dry fit. I'm just going to smear a piece or a knob, if you like, of heatsink paste. So some heatsink paste. The reason I'm doing this, it's good practice anyway. This, as a shunt rig, does actually run quite warm. So I want this chassis to be used, excuse me, as a heatsink. So we go. Do away with that. Oh. Start it with my finger. Nicely nipped up like that. Let's use the proper device. There we go. Posi drive. So that's in place. Sorry, this is in place. The capacitor bank's in place. If you wanted, you could paint this if you wanted. I'm not going to bother. We're now going to go and fit this mighty transformer. Something like that. I'm going to find the fixing. It's around somewhere. I'll see it. So tip it on its side. Offer up the bolt, align the hole. This is a bit tricky because the transformer is very heavy. Sorry again. Now before I nip this up in its entirety, I'm just going to move this round so that the cables nicely go down the side. That'll be fine. So align the cables with the chassis, do that up nice and tight. So there's all the components fixed in place. In actual fact, I should have put this on later. I've got a couple of bits of wiring that needs to be attached to here. I don't know whether I can get to that, get to those screws. That one might be a bit iffy. If not, I can use a spanner. So that's that bit done. Inside here there's a little 4K7 half watt resistor to drop the voltage we're going to come off of here to supply a voltage for this LED to tell you it's on. So there's all the bits in place. I'll be back soon. I forgot to switch the camera on whilst I was doing a bit of wiring. Do apologise, but I'll explain it away here. So I've now got, I finished all the drilling, fixings, doing a bit of wiring now. First job I normally do is the earth. So the earth is strapped to the chassis of the mains, and we have the primary 240 volts. I'm in the UK, so it's 240 volts. Comes down into the transformer, and we've got secondaries that come out. AC is 24 volts AC, and that goes into this rectifier bank here. There's an internal fuse. There's no fuse on this here, so I've had to put an internal one here. No fuse in it yet, but it's just a rough and ready. There you go. And I'm now going to carry on. Now I have to, this is the AC into this rectifier bank, and this is the DC out. So this one here has a positive, this is a negative. So this positive one has to go to the positive side of this capacitor, which in this case is the right hand side. Then everything is fed off that onto the board. This is the negative, and all the zeros will go back to this one here, and back to that. This one goes from here back to this one here. So I'll carry on making this up, and we'll see how we go later. Be back. So I just want to prove that what I've done so far, all this wiring, I've checked, double checked and triple checked that all this wiring is all correct, and that the secondaries are correct back to there. I just want to prove that the what DC we're going to get out this rectifier bank is what we're expecting. Nothing should go bang anyway. So I'll just connect my meter up. There we go. So there's nothing on the meter. I'm just going to hit the button. So we have 24 volts DC out of there, which just so happens that's what we want to come out of here. But when we connect the DC to this capacitor, this will multiply by 1.414 I think it is. So we'll have 30 whatever it is. Let's do a quick, I'll try not to get too technical. Calculator, go there. So we've got 24.5 times 1.414. We're going to get 34.6 volts connected to the capacitor. So that'll be my next port of call when I've wired in the capacitor, and we can see that. So I'll be back shortly. So just to prove it even further, I've connected up the positive from the rectifiers to the positive of this capacitor, and the negative to the negative here. And I don't know if we can see that. No, we can't quite, can we? Oh, there you go. So now we're going to power up and see what we get. So now 35 volts. There's thereabouts. So there's a bit of a loss across these diodes through this capacitor, but I'm now going to wire up the supplies and the earth to this regulator board, and that's going to regulate it down to about 24 volts. So we've got a 10 volt drop So there's a lot of headroom. That's a lot of headroom. But it's always good to have a little bit too much than too little. If it's too little, it won't regulate, it drops out. But so far, so good. So I'll power this off, and you'll notice now that this doesn't just drop. It will drop, fade away, fade away, fade away, unless I put a stinger across it and nullify the power, the energy that's stored in this capacitor. It could stay like that for a very long time. But if I sting this is a stinger. This is just a real makeshift. It's a big 4 ohm 50 watt resistor, and we're just going to short out across the terminals. There's no juice, and it will just kill it. Gone. You can see it trying to regenerate. Do it again. There you go. And it will regenerate again. But it's now pretty safe. There's no energy. We're not going to hurt anything with this now. So I'm going to carry on and do a bit more wiring and come back. Speak to you soon. So I've done a bit of wiring. So I've used these eyelets, typical eyelet, this type of thing. And I've stacked up some wires on here. So this is the negative. This is the negative, or the ground, if you like, call that the ground. So the ground goes off to this BNC. We've got 2 grounds go back to here, in effect the start earth, and then that goes back to the negative on the rectifier. I'm going to stick another couple of wires on here, 3 wires actually, come across, go on there, and then from here we're going to go out to supply the BNC. So that's how far I've got so far, and I'm just using, this is a bits and pieces thing, as I said. It's all bits of wiring I've had laying about. I've got drawers full of the stuff, but this, sorry I keep knocking it, what I'm actually using, this is PTFE silver wire. It is a bit of a swine to work with, but it's PTFE coated, but it's very good. So I'll carry on, come back later. So it's nearly completed. These DINs I've wired up back through to the outputs of the regulators here, one at a time. The positives go to the inputs, the blacks go to the earth or grounds, go back to there, and they go back to the diode pack. I'm just going to do a couple of little things. Just going to double check these are done up tight. This one wasn't. Nice and firm. I'm just double checking all the soldering. That's good. That's good. I'll put a bit of sleeving on here on the DIN. So now it's time. I'm going to tidy all this up on the left with some zip ties. As I said, it's a very rough and ready from bits and pieces that I had lying around. I've been in the bins on the shelves for years. We've got our earth on. That's all fixed. So I think it's time to power up. Yeah, I've yet to connect the negative to the LED, but I'm not worried about that at the present second. We'll just see if we've got what we need, which is about 25 volts. You can see that. So I'm going to go on to the negative terminal here, and we'll go on one of the outputs here, like that. This is where it might go bang. Hey presto. Whoa, 25 volts DC. So that's that one confirmed. We'll just pop this across to the other one. And 25.4, that's close enough for me. So for all those critics that will note that the opening thumbnail says it's a 24 volt supply, but thus far we've got 25 volts. So I'm just going to adjust this. So we've got 25.2 on this reg this side, and we're going to adjust this back to 24 volts. If I can get my screwdriver in there. Or thereabouts. We make both of them 24.2, something like that. 19, 24.2. There we go, that's that one. So just chop this over to this side. We got 25. Very small, minute movements, just a little tweak. Then you've got to wait for the reg to settle. That'll do me. So that's it set up, and I'm going to put a new fascia on the front and a bit of film on the back just to tidy it up, just cosmetic. But that's this section. Speak to you soon. So that's it functioning, working perfectly. It's just left for me to tidy up a few bits and pieces, and then come back, get rid of all this detritus that's all over the place here. Bits and pieces, give it a blow off, make sure there's no little bits of wire anywhere. And I'll tie this all down nicely. So we've got an LED on the front. The LED comes off of the positive and the negative. That's it for now. I'll be back shortly. So I've tidied up a bit of wiring here. LEDs in now, illuminated, soft green light. Move that out of the way. It's been on about half an hour, 20 minutes, half an hour, and we're running, see that, yeah, about 34-35 degrees. So it does run warm, but this whole chassis and the case it's going to go in, that's going to be its heatsink. It's a massive heatsink. So I'll just drop that off there. I'll repeat, this is all rough and ready, but if you've got some bits that you want to use, absolutely ideal. So I'm just going to put a bit of a finishing touch to this. It's again, it's nasty, cheap. It's just a piece of textured vinyl, what they use in sign writing and or automotive. But it's a little trick. Just warm it up first. Get a little bit of heat. This has all been cleaned off. this proper Blue Peter fashion, sticky back plastic, just over the edge, over the lip like that, go along, and then gently tease it down. If I lift this up a bit, you get the idea. The idea of the heat from the gun, it releases the adhesive better, makes it stick. He says, who knows. We'll just go along the back. Right. I'll just whip along the sides in a second with a very sharp implement when I find it. With a scalpel here, we're just going to whip down the edge. There we go. Trim that off nicely. Now there was, as you may have noticed, an LED, and it's a 5mm LED, and all I'm going to do is cut the hole out that was there for it. It's only a push fit, and that will push through nicely like that. So there's a sort of a nice fresh refresh to the front. I'm going to do the same on the back, and that'll be it done. Tease that down. So it's going in the sleeve, tuck everything in, it'll just slide in just like that, roll it over, got some feet. Just like that. As I say, it's only for me workshop. Bit of entertainment for you. Thank you very much for subscribing, all those subscribers. It's not difficult, it's not rocket science. And you end up something that is, in my opinion, far superior than a retail product, if you can put up with the aesthetics. Thank you very much, and my regards to everybody. Have a good Christmas. I'll come back in the new year with some more, maybe of better interest, but for now, with the bits I had, I hope that you enjoyed it. Cheers.